Welcome back everyone to the course on network security and penetration testing, and we are covering a book for that called Guide to Computer Forensics and Investigations. In our previous lecture we covered about live acquisitions and some tools that are used, and these are the tools which we are using in order to capture the RAM and the data in that. Different tools for Windows as well as for Kali Linux, and GUI tools are easy to use, but they often require a lot of system resources. Not the latest ones which are available out there these days, but previously we could say so. It's not the case in most of the cases, but yes, the graphical user interface tools requires a bit more resources as compared to command line tools, and sometimes the command line tools are more effective than the graphical user interface tools that we are using for forensics analysis. Now we would look at the network forensics analysis. Network forensics are a process of collecting and analyzing the raw data and tracking the network traffic. This is how to track an attack carried out and how an event occurred on a network. Intruders leave a trail behind. Knowing your network's typical traffic patterns is important in spotting the variations in network traffic. It can also help you determine whether a network is truly under attack or not. Now, that plays an important role whenever we are investigating a machine or a server which has been compromised. We are very much interested in knowing that the penetrator came from which address, whether it was an external entity or someone is trying to launch any kind of attacks within the network. So we'll have to monitor all the traffic which is going out of the network and coming in from the network from the external sources. So we'll track that even if someone was using a machine within the network, or a machine has been compromised which is being used to target other computers where the traffic is coming, and the best source to get that information is from the corporate firewall. Firewall gives us all the details about the traffic and everything. Further, we can contact the network administrators in order to find the pattern and in order to check the flow of the traffic and everything which is required for the forensics analysis. Now, the network forensics examiners must establish standard procedures for how to acquire data after an attack or an intrusion. We all know that whenever something like that happens, maybe they can wipe out some details from the machines which they were using, or the data that has been compromised, their traces and stuff like that. It could be wiped out, but the details about the network traffic and all those things, they still remain on the firewall or on the switches through which they can get the details. Now, the procedures must be based on an organization needs and complement network infrastructure. The network administrators are very well aware of the overall setup of their network. NIST created a guide to integrating forensics techniques into incident response, which helps us in investigating these things further. Now we'll see how can we secure our network. Securing a network means you must have a layered network of defense strategy, set up a layers of protection to hide the most valuable data at the innermost part of the network layer. We categorize data, or we divide the segments of the data on the networks in categories. Each category would have different access control lists, and they'll not be able to communicate from one layer to another. For example, in educational institutions, we have three different categories. We have students or student labs, we have faculty, and we have staff. So the subnet for each category must be different. It's not like students will be able to penetrate from the student labs to the faculty and staff, and the staff must be blocked access to the student labs and vice versa. Further, the traffic which goes from the faculty, staff, or students must be limited to the ports which are required. Not everyone must get access to the data center or the servers which are there in an organization. Limited IPs based on the MAC address or the IP address, username and passwords. Lots of protection should be there. So it's not like if the computers in the student labs are compromised, all other PCs will be compromised as well. There shall be different username and password, security policies, firewall, and their policies should be there in order to segregate the traffic for different kind of users. Deep in defense means that similar approaches are developed by NSA, which we must follow. Now that helps us in finding different things. For example, if we are implementing any intrusion detection systems, IDS or firewalls or penetration testing, etc., must be carried out on regular basis in order to avoid any kind of problems in the future. Now there are three modes of protection. First of all, people. People means that everyone in an organization, employees and the staff, whoever is working in an organization, must be totally aware of the threats and the policies of the company through which they must comply in order to avoid any kind of problems. When we are talking about technology, it's about using the up-to-date resources or intrusion detection systems, as I told you, or firewalls or latest up-to-date antivirus solution softwares, etc., which can protect you from these kind of attacks. Third thing is operations. These are day-to-day operations, updating the patches on the computers, updating the operating systems, updating the antivirus, anti-spam, and even the spam filters on your exchange gateways. By adopting these things, we can minimize the risk. As we discussed it earlier, we cannot stop it 100% because every day there is a new thing or a new technique which is being used by the penetrators on the networks. Now, network forensics can be a long, tedious process. Standard procedures that is often used is always use a standard installation of the image on the systems or the network, whatever you are installing. But what I would suggest is that, as I told you, three different categories: students, faculty, and staff. Images of all of them must be different, different settings, different username and passwords, different configurations, so that if a set of machines are compromised, your other machines must not be affected by those machines. Fix any vulnerabilities after an attack that you'll identify that something took place because of these problems. So you must take precautionary measures based on that. Now we know that by mid 90s, approximately 90%, 70% of the network attacks by caused by the employees. So they must be updated. They must be there must be constant emails from the network security department that these are the known vulnerabilities or the latest outbreak of a virus or a technique through which they can penetrate in the computers, and they can get information about that. Most of these smaller companies which are there, they are not very much interested in penetration testing within their network and stuff like that. So employees end up revealing proprietary information to the competitors. Now the increasing use of the internet has caused a sharp rise in the external threats. Since all the devices and everything is connected to the internet, external entities are getting an easy access to the network and getting the details there internally or externally by collecting all that information. Now, if we gauge the threats which are there from within the network or from outside the network, now it's 50-50 because the attacks which are coming from outside are equal to the people who are not aware of it. They are downloading the files or the attachments that they are receiving through the emails. They are not reading the procedures while downloading it, thus ending up compromising their own computers and the network. Now, fix any vulnerabilities after an attack. Attempt to retrieve all volatile data that you have. You must keep all that data secure, updated, and make sure you have multiple copies of backups of that data, so that if you detect that something took place at a certain date, you can at least have the data safe beyond a certain date for which you can keep it. So you'll have to only monitor the things which happened during a certain period of time. Acquire all compromised drives, keep them separate, monitor them, as we discussed earlier, collect the hash codes of it, and then try to find out that how much files has been compromised or changed on an operating system. Compare the files on a forensics disk to the original installation, as we discussed earlier. Now in digital forensics, you can work from the image to find the most and the deleted or hidden files or partitions which are there in the hard drive. In network forensics, you have to restore the drive to understand the attack. It means you'll have to simulate the network, the kind of an environment on which it took place, and see what are the vulnerabilities on through which channel or port the penetrator penetrated inside the network, and then how he managed to bypass the security protocols. Now, reviewing network logs are very important whenever we are trying to get the details of about any penetration, whatever took place on the network. Now, network logs are available on the network servers, routers, and firewalls. Now, there are different tools available in order to generate the dump of the traffic that was there. For example, for network traffic running, we can use TCP dump as mentioned over here, and Wireshark. There are different tools available for that. We'll be discussing about it in a while. Now, TCP dump is a command line program tool with the help of which we can find lots of records about what happened, it came from which port, it went from which port to which port, and all those details. For example, if we are checking, it would tell us the date of it. It would tell us which port was it, what was the interface, what was the size, and what was source and destination. Source and destination plays an important role because it tells us that from this source to this destination, and from this destination to this source. So it helps us in finding a map of the traffic that wherever he actually went throughout the network. It even tells us the ports which were used in order to transmit those kind of traffic on the network. So we can check, for example, if he was using a suspicious port which is not allowed on the network, and somehow if it was open on the network, you can get those details from there. So that's how we can identify the pattern. There are a variety of tools available in order to do that, like Splunk is there, Spice Networks, and iOS and Cacti. So lots of different tools are available on the internet. Some are free, some are proprietary tools, but it depends what kind of situation you are in and what are the best tools for that kind of a situation. Now, there are different packet analyzers available out there with the help of which we can analyze the traffic on the network. Devices or software that monitor the network traffic mostly are on layer 2 or 3 of the OSI model, which is the basic layer. To understand what's happening on a network, often you need to look into the higher layers of the network using custom software that comes with the switches and routers. That gives us a very in-depth information about what's going on the network. Some packets can be identified by following the the packet capture format, or identified by examining their flags like TCP headers, etc. Now that helps us, for example, if your network is under a SYN attack, which is synchronization portion of TCP handshake. In a SYN flood attack, the attacker keeps on asking for your server to establish a connection. Although your server can handle thousands of connections, it can handle only a limited number of established connections. Now, in order to find that, you'll use TCP dump and Tetherreal, a network analyzer that can be used as a program to examine the TCP headers to find the SYN flags. For example, in this picture, we can see what's going on. We can see the TCP header in the port, and the flags are containing this, including the SYN flag, which is available. It's coming either from a 16-bit or a 32-bit, which is a source port is a 16-bit and the destination port on a 32-bit. Then we look at the sequence number of it. We can observe the flags using the window, and then we can check the checksum of it, and then look at the pointers of it, and then we'll end up having an option and a padding. You can clearly see it in Wireshark if you'll be using it. There are other tools with the help of which you can see it is mentioned in your book. For example, you are using a Wireshark or packet analyzer with the help of which it gives you a traffic of the UDP stream traffic appearing on the computer. You can even check different flags on it and check the traffic where it's coming from, the IP address, source, and destination, even the server details, etc. So all that relevant details will be available using Wireshark. Investigation of a virtual network is totally different than a physical network because we don't have a spanning tree between the virtual switches. Now that means that in a network, for example, if you are setting up a virtual switch on your hypervisor, it could be a type 1 or type 2, but take for example a type 1 hypervisor. You're setting up your own network. It has different computers and their own IP addresses and virtual switches and everything. The second set of a network that you are making on the same network, it can also have the same number of IP addresses and virtual switches and everything. But since there is no standardized format of it, there is no overlapping and everything. Both can work independently without interfering with the network and the switches of everything. The IP addresses could be the same, the MAC addresses could be the same and everything. But since we are not worrying about all of them being on the same network, each individual party can have or maintain its own set of IP addresses and MAC addresses. So there is no subnet mask or anything like that which they must be concerned about. In that case, each VM can have a virtual Ethernet adapter and a virtual network interface card with the same IP address and same MAC address can appear on the second student's network adapter. Each student on the network can detect the other student or the student's network because the virtual switches which enable each student to create a large number of independent or other students is limited to only allocated RAM and the storage capacity plus the login credentials which are provided, which could be different in all computers. Now, hypervisors can assign MAC addresses to virtual devices, which could be different in every case. Devices can have the same MAC addresses on different virtual networks. We have tested it. Okay, so the devices can have the same MAC address on different virtual networks. Cloud service provider hosts network to several hundreds of companies and the IP addresses, etc., which they are managing on their own servers. Then we can use different tools like Wireshark and Network Miner in order to investigate the things on the network. Now let's see what can we do or what do we think about examining the Honeynet project. Now, the Honeynet project was developed in order to make the information widely available in attempt to thwart the internet and network attackers. It provides the information about the attacks, methods, and how to protect against them. Think of it as a forum where they are going and they are getting all the latest information about what kind of attacks are taking place and globally what are the procedures in order to protect yourself from those kind of things. So the main objective is awareness, information, and tools. So if you'll be aware of it, you can take preemptive measures in order to avoid those kind of problems. The information will be available over there, like the impact factor and the devices or the kind of operating systems which is actually targeting at, and then they'll even discuss about the tools that we can use in order to avoid those kind of a problem. The major threat is a distributed denial of service attack, which is taking place in most of the organizations. The traces of the DDoS attack might go through the organization network, not just your own ISP. In DDoS attack, hundreds and even thousands of machines can be used in order to collectively launch an attack against an organization or an enterprise. These machines are known as zombies, which are controlled by external entities because they have unwittingly become a part of the attack. When the first DDoS attack begins, the main concern were the high monetary impact and the amount of the time it took to track down the attacks. After the major threat in a zero-day attacks, attackers look for holes in the network and operating system and exploit those weaknesses before patches are available to fill in those gaps. So they'll find the known vulnerabilities in an operating system and then they'll try to exploit that. Vendors usually aren't aware of these vulnerabilities exist, so they don't have developed the release patches for them immediately. It takes some time in order to get those patches to be released and to be applied on the network. Penetration testers attempt to break into the networks to find the undiscovered vulnerabilities and then predict that where the next onslaught of the network attacks will come from. So you'll have to keep an eye on all the weaknesses of your own network. Now there is a very interesting concept called a honeypot. Is a computer setup to look like any other machine on your network. Its purpose is to lure the attackers to your network, but it contains no information of the real value. You can take a honeypot offline to analyze it and then affect the running of your network. Honey walls are the computer setup to monitor what's happening to the honeypots on the network to record what attackers from within the network or outside the network will use. Honeypots and honey walls are commonly used to attack the intruders and to see what they are attempting to do on the network. It's kind of a track point for the users which are inside the network or from the outside the network. We'll place a machine deliberately over there, which would be an open kind of a threat or a machine. So we'll see that who is coming towards that machine and would try to do some activities or would try to use certain tools. Now you might be able to identify some users within your network who are sometimes doing it for fun. Maybe they have some skills and they are trying to penetrate in the machines thinking that we found a machine open and we can do certain things on it, but actually it is spotted over there in order to identify those users. Now if we'll see, I think that's the end of the chapter, and if you have any questions or any concerns, please feel free to drop me an email. That's it. Thank you very much.